Hello everyone, my name's Frances Lukazik and I'm a conservator here at the Mac Lab. Today we thought we would tell you about one of the things that makes the Mac Lab special, about some of the equipment and one of the treatments that we do here. And that is the conservation of wet or waterlogged archaeological wood. So in the conservation of wet or waterlogged archaeological wood, one of the specialized pieces of equipment we use is a freeze dryer, which I will talk about a little more later. But first I'm going to tell you about the special environment that's needed for that wet archaeological wood to survive. And that's in a dark anaerobic environment, which means it's oxygen free. You don't have bacteria that's causing the wood to decay, or bacteria that will completely eat away the wood structure. You may be wondering or asking yourself now, like, well, why can't you just set the wet wood out in the lab to dry? And one of the reasons is some of the awesome properties that water has that you may not know about, which is surface tension. Yeah, to demonstrate the property of surface tension that water has, we're going to float a paperclip on top of the water. Okay, so we can see that the paperclip is happily floating on top of the surface of the water. So to disrupt the surface tension that's holding that paper clip up, I'm going to add a small amount of hand soap. And the soap disrupts the hydrogen bonding so that the paper clip falls to the bottom of the beaker. So what happens is when that wood is immersed in that waterlogged environment for centuries, water has time to migrate and occupy the cellular structure of the wood. So over time, that water is providing support to the wood structure. Or once that wood is excavated and removed from that waterlogged environment, the water is still supporting the cellular structure of the wood. And so if we just set the wood out in the lab to dry, what happens is as the water evaporates, it pulls on the cellular structure of the wood, which causes cellular collapse, which is what causes dimensional change, such as warping and cracking. And once that happens, that cannot be reversed. It's irreversible, and then oftentimes the wood artifact will look nothing like what it did when it was first excavated from the site. Oh, as a reminder and further illustration of why we don't let the wet, waterlogged wood set out in the lab to dry, I have a couple of sponges here. So sponge here is fully saturated with water. Other sponge has been set out to dry in the lab, and you can see it is completely dry and also misshapen and deformed, and no longer resembles the flat sponge that it was when it was fully wet or saturated with water. So now that I've demonstrated why we can't just set the wet archaeological wood out to dry in the lab, I'll tell you about the specialized treatment that we use to preserve the dimensions of the wood that will also provide the stability for the artifact to be around for the generations to come and available for exhibition, research, and so on. So the treatment that we use has actually been used for decades in the conservation profession. And the treatment involves immersing the wet archaeological wood into a solution that includes polyethylene glycol dissolved in water. And so polyethylene glycol is actually a compound that's found in a number of our household products, so it's not toxic. It's very compatible with water and the organic nature of the wood. And so what happens, once the archaeological wood arrives here at the lab, we will clean it to ensure we've removed all the soil. So once the archaeological wood is clean, we will then find a container or a tank that all those wood artifacts will fit into, and they will stay immersed in a solution of the polyethylene glycol. Could be for weeks, months, even over a year, and that's based on the condition of the wood and the species of the wood, and of course also the size plays a role as well. And so what is happening inside that tank is the polyethylene glycol is migrating into the wood and pushing out the water that has been occupying the cellular structure of the wood. So the goal is to remove as much water as possible from the cellular structure and provide a new support. So after we've determined that the wood has been in the polyethylene glycol solution long enough to replace as much water as possible in the cellular structure of the wood, then we'll move to the next stage of the treatment, which is what we'll do is we'll remove all the wood artifacts from the solution, and we will place them in our walk-in freezer. And what we're doing is, in the freezer, any residual water that's left is going to freeze. And the polyethylene glycol all this time just remains inside the wood. After the artifacts have been in the freezer, and again, amount of time is dependent on the size, thickness of the wood. We'll then take it out of the freezer and we'll move to the final phase, which is the controlled drying of the wood using our freeze dryers. And we are fortunate to have two freeze dryers. One that you see here is quite large. The chamber is 12 feet long and 4 feet in diameter, so we can put some very sizable timbers inside there. And then we also have a smaller freeze dryer, which we consider our workhorse, and we also conserve, in addition to smaller pieces of archaeological wet wood, is also wet leather artifacts, which are treated in a similar manner using polyethylene glycol. So you may be wondering, why use a freeze dryer? So the freeze dryer allows us to complete the drying of the artifact in controlled conditions under vacuum. And you may be wondering, what's going on inside the chamber of the freeze dryer? So, like I mentioned before, there's always a bit of residual water left in the archaeological wood, even after it's been immersed in a polyethylene glycol solution. So we want to avoid, as I said, the damage that's caused by water through evaporation, that liquid stage of water. Inside the chamber of the freeze dryer, under vacuum at cold temperatures, we are able to bypass the liquid stage of water because inside the chamber, the water is shifting from a solid, like I said, the wood is placed in our walk-in freezer beforehand to freeze any residual water that's in the wood. So when it is moved to the freeze dryer under vacuum, that frozen water shifts from a solid to a gas. So it bypasses the liquid stage of water, which causes damage. And so if you may remember from your early science classes, chemistry classes, that process is called sublimation. And so this allows us to complete the drying of the wood without having those dimensional changes, such as warping and cracking occurring in the wood artifact. So while the wood is inside the freeze dryer undergoing final stage of the treatment, periodically we'll take the wood out and weigh it. And so what we're looking for is the weight of the wood to stabilize. And once it does so, then we know that the drying is complete and we can take the wood out of the freeze dryer. And at that point, treatment is complete. The polyethylene glycol that I mentioned before just remains inside the wood and continues to stabilize the cellular structure of the wood. Yeah, so the large timbers that you've been seeing periodically throughout this video are from the Carlisle warehouse. They represent the foundations of the Carlisle warehouse that was excavated in the city of Alexandria. And what makes the warehouse building special is that it's considered the earliest public building in the city of Alexandria.